Hello everyone, today we'll be talking about the basics around SF Sprite and SF Texture. Before we get into that, I've made some adjustments to the cmakelist.txt. I have said that our project name is now SFML game, and for the executable, I've made that SFML game, same with target, compile features, and link libraries. We've done that so that we don't continuously have to make unnecessary changes to our CMake lists. We have chosen some generic SFML game that we will use throughout this course. Alright? Also in main, for the render window, I have changed the render window name to SFML game. Other than that, the code is identical to the setup guide for SFML. I have also created a folder in our directory of this project called assets, and in that folder assets I've made another folder sprites, and in that folder sprites I've put spaceship.png, which will be our example texture that we will be using today. Alright, let's talk about SF texture now. An important thing to note is SF texture, if we look at its actual definition from SFML, they say that SF texture is simply an image living on the graphics card that can be used for drawing. The important part of the sentence is this for word. It's used for drawing. That means we cannot directly draw an SF texture to our render target, which in this case is this window. We must first apply it to a drawable object and then draw that drawable object on the screen. Now, what is a drawable object? In SFML, there's a class called SFDrawable, and this class is an abstract base class for objects that can be drawn to a render target. Drawable objects will inherit from this drawable abstract base class. Some examples are SFShape, and another example is SFSprite, which we will be talking about today. An SFSprite is a blank canvas that will take the shape of whatever texture we give it, whereas an SFShape is a primitive object like a circle, a square, things like that you don't have to create a texture for, right, if you don't need to. Okay, most of the time we will be using complex objects, so we will need to be using many SF sprites. Alright, now that we've spoken about that, let's go into actually making our own texture. So what we do is we say SF texture, and in this case we're using the spaceship PNG, so we'll call it something like spaceship texture. Alright, and we will default initialize it. It's important to know that in this constructor, you can directly pass the file path to our image spaceship.png. However, I don't recommend that. I recommend first creating the texture like this to avoid any undefined behavior that is a bit difficult to debug. Okay. Another thing to note is that wherever you create this texture and whatever you apply this texture to, that object that you apply it to needs to live the lifetime of that object needs to outlive this texture. If this texture goes out of scope and the object that applied that texture is still using that texture, some strange things could happen and we get undefined behavior, crashes. It's all bad, okay? So usually what you would do is these textures would be created at the beginning of your program and persist throughout the entirety of your program. And that's fine because many objects can reference the same texture, alright? They don't need to have their own specific texture if they are using the same image. Think of bullets, for example. You'll have one bullet texture and many SF sprites referencing that one bullet texture and applying it to themselves, alright? That way you avoid any undefined behavior, and we will continue to do that throughout the course of this demonstration. So okay, we've made our texture. Now we want to actually load that texture from a file. And that file is assets, sprites, and it is spaceship.png, just like that. Okay, that will now load our texture from this file and save it into this texture object. However, it's important to note that if you hover over load from file, you'll see it returns a boolean, and this boolean returns if it's successfully loaded from that file or not. So a good practice is to put this in an if statement and say if not successfully loaded this texture from a file, we will then have to include IOStream here, include IOStream. We will output a error saying error could not load texture spaceship texture std end line, and we will return 1 for an error. Okay, that is good practice to put in an if statement so that if it fails, we catch it and we actually output an error for it. However, load from file, most of the time it does that itself, so you'll get double logs, but again, it returns a boolean for a reason, and we should always be doing this as good practice. Okay, now we can assume that whatever we do, it's successfully loaded, the program's running, and everything is fine. We need now a drawable object to apply this texture to, and in our case, we are going to be using an SF Sprite. Okay, drawable representation of a texture with its own transformations, color, etc. Most of the time in games, we will be using SF Sprites and not SF Shapes. Okay, because again, in games, we are working with complex objects. And we are going to call the sprite our spaceship. That's in the constructor. You can see that the most popular one is to give it a texture. So we will be giving it a spaceship texture above like that. Okay. Important thing to note is SF Sprite itself. If we look over here, I believe it should be somewhere over here. It's either uncommon to create a sprite object without a texture constructor, or it's not allowed. I cannot remember which one. However, most of the time we will be giving it a default texture as it's just good practice. All right. Now that we have applied this texture to our sprite, what we can do is we can simply draw it to the screen to actually see this texture. Now, where do we draw it? Okay. In the while loop, this is our main game while loop. So we are checking while is open. All right. Then we'll see we're checking for events over here. And after we check for events, we clear the screen of all objects and fill it with black. That's the background color. And finally, we display all objects that are drawn to the screen. So we are going to, before doing that, displaying the objects drawn to the screen, we are going to draw our spaceship. Now, if you put this window.draw spaceship, if you start drawing objects before you clear the window, so if we put this over here, then what will happen is we will draw the spaceship, but then it will clear the spaceship and then display nothing on the screen. And if we put the spaceship after the display, it will display all the drawn objects, but we haven't drawn the spaceship yet, so we won't see it on the screen. So that means that the perfect place to put it is between clear and display, and that will always be the case. Okay. Now, looking at our code, we should see a spaceship on the screen. So let's build our CMake file. We go look in our bin, and instead of SFML game, we are, instead of just game, I'm not sure why this is over here. We renamed CMake list to SFML game. So we are going to take SFML game. We're going to run it, and, well, we don't see a spaceship, do we? But we see this little outline bottom right. Okay, interesting. Let's close our application and let's go have a look at our spaceship image. What that looked like was the tip of our spaceship, a curve of it. But it was extremely big and it was off our screen. Now that's an important concept. One thing is the size of these sprites are relative to the PNG itself, and the PNG size is 1928 by 3872 pixels, which is way larger than our window of 800/600. Okay, important to note. Another important thing to note is that we can actually draw things off our screen. The plane of drawing objects in SFML extends infinitely. It's not limited to our visible screen. Alright, so that's an important concept to understand just in general. But how do we fix this now? Well, after we apply the spaceship texture, we want to address two problems, the size and the position. So first, let's address the position. We can use simply set position, which takes an SF vector to F. Now earlier, with our window, we have given the window mode or the video mode an SF vector, which looks like this. We haven't spoken about it before, but an SF vector is simply a struct. Let's look at a vector to F. Is simply a struct that consists of two values, an X and a Y value, of float, alright, and that's really it. I mean, it's got an X value or Y value, and that's it. There's not much more to say. You get things like vector to U, which is an unsigned integer. You get things like vector to I, which is a regular integer. Things like that, okay? But most of the time we'll be using a vector to F. So that's just a little aside note so that we can set the position. We make a SF vector to F, and instead of creating a SF vector to F object like that, we'll be using modern C++ and just construct it in place with our initialization braces. Alright, it gives a much more cleaner syntax for creating vectors in particular, or any object for that matter. We will give it 400.0f because it is a float, and 300.0f. Alright, just as a random XY value, it's kind of in the middle of our window somewhat, we'll be able to see it. Okay, so we address the position. Now we need to address the actual size of the spaceship. Now you might be tempted to look for something like a set size, but for sprites, set size is not a valid function. They have something called set scale, alright? And this sets the scale of our actual image that we used for the texture. Where if we now, again, this is a vector to F, if we now say 1F, this means it's scaled times 1 in the X direction and times 1 in the Y direction. So it will be the exact same size as our PNG, which is not what we want in this case. We want it to be smaller. So we are going to use a smaller factor. And I've played around and found that for this specific image, 0.05 in the XY direction works nicely. Alright? Important to note that if you want to stretch an image in only one direction, then you will only change, let's say, the X value and then keep the Y value as 1. Alright? And that will then stretch or shrink it in the X direction, whichever one you have chosen. Alright? But in this case, we want to decrease the scale of our entire image, so we will apply it in both X and Y directions. Now, we can expect that our spaceship is somewhat in the middle and its scale should be visible. Let's build and see what we see on the screen. Okay, let's have a look. And there we go. There's our spaceship on the screen. But as you can see, if you look closely, it seems to be a little bit jagged in places. It's looking a little bit pixelated. That's due to the size of the image, so that's not too much we can do there. But there is something that we can do to make it slightly better. All right. And that is for images like this that are smooth, aka they're not pixel art. What you should be doing is after you create your texture up here, you should then say set smooth true. And this attempts to smooth out those jagged pixels and make it look more appealing to our eyes. And again, unless you're doing pixel art, you should probably always do this, but always have a look how it looks without it and with it on, just to get a bit of a feel. If we run it now, we can see, okay, it looks a little bit better. You might not be able to tell the difference, but it looks a little bit better. Okay, so let's keep it like that. Now, that should be the end of the tutorial, but I'm going to give you a little bit of a taste of event handling to see if we can actually move our spaceship. So in our event while loop over here, where we poll the window for events, we are going to say auto const key pressed, okay, equals our event that we have polled from the window, get if. I'll explain all of this in a second, or at least the rough overview of it, because we do not need to know in detail right now. Right, just like this. So what are we doing? We're polling our window for an event. If an event occurs, we get into this while loop. We don't know what that event is. We could move our mouse, close the window, press a key on our keyboard. It could be any event. So here we checked if we press the close button for our open window. But over here, we're checking and seeing if a key is pressed. And if a key is pressed, we are using this get if, which will return the actual. If we hover over here, we will see that we get an SF event key pressed. That way, it will enable us to actually extract the key that was pressed on the keyboard. Because again, there's many keys that we could press to enter this event, and we don't want to check each and every single one individually. So we are going to say, if there is a key pressed event, we're going to get it, and we're going to save it as key pressed. Great. Then we can switch on our key pressed dot code. Now a code extracts the actual keyboard button that is pressed on your keyboard from that key pressed event. And as you can see, there's many codes. It's basically every button on your keyboard, right? There's many over here. So, okay, we will switch on the ones that we actually care about, which is the case of SF keyboard key W. Okay, we're then just going to copy this. I'm going to say W, A, S, D, the classic movement keys. Then what are we going to do when we press W? We're going to take our spaceship. We're going to say it moves. Again, here's a vector to F. It moves 0 in the X direction and moves -5 in the Y direction. Okay, and this is important because minus is up on our SFML window and positive for Y is down, whereas for X it's the logical one. Positive is right and negative is left. Okay, what are we going to do now? We're going to just paste this everywhere and we're going to edit it. Then for A, we wanted to move left, so we wanted to move -5 in the X direction and 0 in the Y direction. Then when we press S, 0 in the X direction, but it's going to be +5 in the Y direction because we want it to go down. D, +5 on the right and 0 on up and down axis, aka the Y axis. Okay, let's build this now to get a little taste of event handling. Great, it has built. And now let's run it. Now if you press WASD, you will see that we can actually move our spaceship. Very nice. Alright, and that is the conclusion for an introduction on SFML sprites and textures. We will at some point take a look at sprite sheets, which is the more popular way of introducing textures for our video game characters, which will enable us to do animations. However, that will only be looked at when we get to the animation section, as it's not relevant right now. Thank you for watching.